dear students. Today we will talk something about the result today, but due to the fact that some students could not appear on 13, so they have to get a chance to do, so it'll be on 15 October. Whatever be the case, let me say categorically that judging the mushrooming of coaching centers that would decide the fate of meritorious poor students who could not afford to pay fees in these coaching centers fighting for their supremacy, MBBS study may have been snatched from the deserving poor. So, unless we resort to the old pre-2012 when selection was based on the topper of PCB, physics, chemistry, biology, from state, be it boards, ICSE, CBSE, these tests, very eliminating in nature, will block the students from becoming doctors. Old system had produced many good doctors all over the country. Let us know and think about it. So now I will come now to a different question, a beautiful question by IIT in 2010. This is the cream of physics. Unlike this Neet question, see, incandescent bulbs are designed by keeping in mind that the resistance of their filaments increase with temperature. If at room temperature, 100 watt, 60 watt and 40 watt bulb filaments resistance are R100 ohms, R60 ohms, R40, so R100 respectively. So one of these will be correct. 1 by R100 is equal to 1 by R40 plus by 1 by R60. R100 is equal to R60 plus R40. R100 is greater than R60 is greater than R40, and D 1 by R100 is greater than 1 by R60 and 1 by R40. So if you get this question, please remember only two facts. Don't be nervous, just remember Ohm's law, basic Ohm's law, and then what? This is very important. What equation? Current into voltage. So start from yes. Let's say that the clock start at 0 second. So what is equal to current into voltage? So what is equal to current into voltage, which mean for the same voltage, more is watt and more will be C. See, when watt is more, C will be more. Why? B is same, which means it comes to this, more the watt, less the R. You got the point? More the wattage, less the R. So you have to take only one of the C. The one of this, the correct one will be D. R, 1 by R100. R100 is the least. So 1 by R100, because this is in the denominator, it is the greatest. Subsequently, it is greater than R60 and 1 by R40. And if I calculate the time, it is only 40 to 50 seconds. And see, this is the bulb, this is the filament, and in some book they write it is tungsten filament. That is wrong, because that was in the time of Thomas Alva Edison, in which tungsten was available in plenty. Now they have replaced it by a carbon filament. So remember that. So now carbon filament, no more tungsten. So this is one of the best example. I think students will understand. Remember only this, and then you base your thing. The more the watt, the more the current, the less will be the resistance. Only this, then you can solve it in less than 50 seconds. So now we will come to another one. This is also IIT 2004. It deals with total internal reflection. Total internal reflection is very, very useful, and it is the subject of great research now because we have got 5G. 5G network, copper wires no longer able to deal with gigahertz of frequency of a digital signal. So we have to resort to, we are rescued by fiber optics. And fiber optics is based on total internal reflection. So look here, this is a thermocol, and this thermocol, at the center of thermocol, see it may be 5 centimeter radius, diameter, 5 to 6 centimeter diameter, and here is a stick. And on this stick, you fit one LED here, and with two wire, you can bring it to a 1.5 volt cell, a battery, a torchlight cell, so that you will get the lighting. And preferably, a red LED is better because red LED is the strongest spectrum from all those spectrum of the rainbow. So here, what do you do now? See, OH, you pull OH up. You look from here and you will see this ray will come here and hit your eyes. This ray will come here, and because this is less denser than this, optical denser, it will go like this. When you pull this up and up and up, time will come that this red light LED will no longer be seen by the eyes because the ray will trace along the surface. And at that time, the angle of refraction will be 90 degrees and the angle of incidence will be this. See? At the time in which you have missed to see this, it just disappears from the eye. This is angle C, which is this is angle C, and these are two parallel lines, so C is equal to C. So angle C is equal to this, and the refracted ray is 90 degrees. So this, from this one, you know mu is equal to sine C. So sine C will be R by OB. It will be R by square root of OC square plus BC square. Pythagoras theorem. It is very simple. So now sine C by sine 90. At the time of total internal reflection, sine C is the critical angle, sine 90 is 1. So this is mu of air with respect to water, which means it is same as mu of this one where we have here mu of water with respect to. I have told you about this. Be careful. Mu air with respect to water is 1 by mu air with respect to water. And from here you can find the value of mu. If you know angle C, then sine C is 1 by mu. You will find angle mu. So I have done it by myself. I got it about 1.34 or 1.35. It should be 1.33, but anyway, it is a very good experiment. So here I will just I'll just